So let's start with this problem. Again, the objective of the videos remains the same. Okay, so we'll take a problem. Okay, we'll solve it using all the methods that we have learned so far in the class, like nodal analysis, mesh analysis, Thevenin's theorem, superposition theorem, and we'll see that all these methods they converge to the same answer. Whatever may be the methodology, the answer you get should be the same. Okay, so so let me start with nodal analysis. Okay, so in nodal analysis we primarily identify the nodes and we label them with some voltages and we apply KCL at these nodes. Okay, so in this problem if we take this node as the reference node, okay, so this is one of the nodes. Let me name this VA, and this is one of the other nodes, so let me name this VB, and this is another node, let me name this VC. Okay, so the objective of the problem is to find out the current through this 7 ohm resistor, that is this current. Okay, so now I'll assume some current directions. I am assuming current in this branch to be in this direction, in this branch to be in this direction, and in this branch to be in this direction. Of course, it is very clear from the problem that VA is in fact connected to 1 volt voltage source. Okay, so now we need to apply KCL at these two nodes, one at VB, one at VC. Okay, so try to get a system of two equations with T unknowns and solve for those to get VB and VC. And once we get VB, calculating VA minus VB by 7 will give me the current that is flowing through the 7 ohm resistor, which happens to be the objective of this problem. Okay, so first I am applying KCL at VB. So what does the KCL say? The KCL says at any given node the sum of entering currents is equal to the sum of leaving currents. So let us identify the entering current. So this 2 amp independent source is entering this node VB, and the current through this branch is also entering VB, but the current through this branch is leaving VB. Okay, so on the left hand side let us write the currents that are entering, which is clearly 2 amps. Okay, and this is also an entering current which happens to be I is nothing but V by R. V in this case is VA minus VB by 7. So this is nothing but VA minus VB divided by 7. So the entering current should be equal to leaving currents. In this case it is this branch current, and this branch current happens to be VB minus VC by 3 ohms. So this is nothing but VB minus VC by 3 ohms. Okay, now I know from the problem it is clear that VA is equal to 1 volt. I plug in this value here and I rearrange equation. After 2 minutes of arithmetic or algebraic manipulations, you can see that this equation can be written down as 10 VB minus 7 VC is equal to 45. Okay, let me name this equation 1. Okay, now I'll proceed with the problem. Now I'll apply KCL at VC. So let us first see what are the entering currents at VC, node VC. So the current through this branch, the 3 ohm branch, VB minus VC by 3 is entering VC. This current as well is entering VC. So this is nothing but VA minus VC by 1. We have only one leaving current at VC, that is nothing but the current through this 2 ohm branch, so that is nothing but VC by 2. Okay, so plugging all this. So on the left hand side I am now writing the entering currents. So entering current, one of the entering currents is VB minus VC by 3, that is this current. So even this current is entering, that is nothing but VA minus VC by 1 is nothing but is equal to the leaving current. Leaving current in this case is VC by 2, that is this current, VC minus 0 by 2. Okay, on taking LCM and rearranging the equation, you will see that after few minutes of algebra I'm sure you can also get this. I would get 2 VB minus 11 VC is equal to minus 6, this is my equation 2. Now I have two equations and two unknowns. I solve these two system of equations. I get the values for VB and VC. Once I get the value of VB, remember my objective of the problem is to calculate the current through this 7 ohm resistor, and the current through this 7 ohm resistor is VA minus VB by 7. Okay, so that would finish the problem. Okay, now let me multiply equation 2 with 5 and write it down here. So that would give me 10 VB minus 55 VC is equal to minus 30. Now I'll subtract these two equations. Okay, let me, this becomes plus and this also becomes plus, so this gets cancelled. So this is now 55 minus 7, which happens to be 48 VC. This is nothing but 45 plus 30, which would give me 75. So in turn, what is my VC? My VC is equal to 75 by 48, which is nothing but equal to 1.5625 volts. I'm sorry for this. Yeah. Now I'll plug this VC value in this equation. So what do I get? 2VB is equal to minus 6 plus 11 VC. So VC happens to be 1.5625, and if I solve for VB, sorry, so I'll get VB as 5.59375 volts. Okay, now my objective is to calculate the current through this 7 ohm branch, so that is nothing but VA minus VB by 7. From the problem it is clear that VA is equal to 1 volt minus, so this is nothing but 5.59375 divided by 7. So this gives me a value of roughly minus 656.2 milliamps. Okay, so if a negative current is flowing in this direction, that actually means a positive current is flowing in the other direction. Okay, so the answer is the current through the 7 ohm branch is I is equal to 656.2 milliamps, or I can say that I is equal to 656.2 milliamps, and the direction is it is actually flowing from node B to node A. So I'll mention it this way, from node B to node A. Okay, so this is the answer. Okay, so let us see if we get the same answer using the other